Hey guys, wanted to talk to you a little bit about machine shop pricing. I got a guy come in the other day and I gave him the price on the job that we did, and you know, he looked like he was insulted by that price. And what he said was, well, all you did was rebuild the cylinder head. Why is the price so high? Well, machine shop prices are pretty expensive, mainly because I don't think a lot of people really understand what all goes into rebuilding a head or an engine or so forth. There's a lot of stuff. One of the things that happens is the general public out there, customers, consumers, car guys, whoever they are, they want to have an engine done, but what they do is they watch, you know, Speed TV, or they watch, you know, Overhaul or some of these shows, and at the beginning of the show they have this old dirty nasty core, this old ratty car, and 45 minutes later they got a completely rebuilt engine and a restored car. There's a whole lot more to it than that. They're leaving a bunch of stuff out, and so the general public, a lot of people out there, they don't really fully grasp what it takes to rebuild a head. A good example is I've got a 6-cylinder back here. Now this is a Ford. It's a Ford 6-cylinder. It's an inline Ford. It's a 200 cubic inch inline 6-cylinder off of a late 70s. I don't know if it's a Ford Granada or what it is, but the customer brought me the head and the head was cracked. Okay, well, this particular head has an integral intake manifold. It's the 206 cylinder, and unfortunately there aren't any of these heads around. You just cannot find them anywhere. He went back to the boneyard 3 or 4 different times, and every single head he brought me was cracked. Well, it's very typical of the 200 inline 6-cylinder. Also the 250 is in that engine family as well. It's very typical that those heads are cracked. They crack like crazy. Probably 90% of those heads that you find anywhere nowadays are going to have a big crack in them. So we made the determination. There is a shop here in town that does cast iron furnace welding. So we made the determination, because we couldn't find a head, that we were going to get the head welded. So I send the head out to the welder. Well, the welder has this head for about a month and a half. They were just really backlogged. They're the only game in town here in Phoenix, Arizona that does furnace welding of cast iron, so I just had to wait. So I finally get the head back. There was a lot of trimming work and a lot of more work that had to be done to the head. I actually ended up having to put, when they welded it, they put 3 exhaust seats in themselves and then pressure tested the head, and they put exhaust seats in the area where the weld was, and then pressure tested and made sure it wasn't leaking. The entire area where they welded the combustion chamber, I had to get a Dremel tool and a die grinder and reshape that combustion chamber and basically, you know, make it into what the shape that it needed to be. Then I discovered that the guides were bad, so I had to put all new valve guides in it on the seat and guide machine. Then I started cutting the seats, and I discovered that several of the other exhaust seats that they didn't replace were sunk. They were not. They were just too deep, and so I ended up having to put it back on the machine and put seats in it. And I had this thing off and on the machine 5 or 6 times. I had to mill it. I had to set it up and mill it, of course. And I had to mill it extremely slowly because of the area that was welded on the surface was hard. So I probably spent 2.5 to 3 hours on the mill for machine time there, not to mention the setup of the machine. I mean, there's just a lot that goes into it. So I basically, what I want you to do is I shot some video, and I'll narrate it as we go, because I basically shot the progress of this head being rebuilt. Because you need to understand, when a machine shop quotes you prices and it seems like an outrageous price, man, there's a whole lot that goes in, especially when you're getting a head welded or you're getting stuff repaired. There's a lot of work that goes into that, and I think the average person out there really doesn't understand it. So, you know, and I finally got the head together today, and I got the parts. I got the springs here. I got the new valve stem seals that I ordered and the keepers. So I go to put the head together, and I discovered, guess what? Wrong valve keepers. These are 11/32, and these have a 5/16 valve lock or valve keeper. Okay, it's It's 11:10 at night. I've been working on this head now off and on for about a week, and today, just today, I did all the seat work and everything. I've been working on this head since 3 o'clock this afternoon. It's 11 o'clock at night. So when I hand this guy a bill for 650 bucks for an inline six-cylinder, you know, a lot of times you do that and then the guy just about craps his pants. But the fact of the matter is that, you know, there's a lot of labor. In this business, we sell time. You can't find this head anywhere. We had to put the time in it to rebuild it. But I can tell you, these keepers, about 20 minutes ago when I discovered these keepers were wrong, that was about the time I decided, you know what, I am done working on this head. The bad thing is we had to order these keepers. They were special order. Nobody in town has them. It's a 5/16 valve stem with a single groove. You can't go down to Napa or AutoZone or somewhere and buy these keepers. You actually have to order them, and it takes 3 or 4 days to get them. Ugh. So that's just the way it goes. It gets frustrating at times. And what makes it even worse is when the customer looks at you like you're trying to rip them off after you've gone through all this. So the video that I'm going to show you next was shot earlier today and earlier in the week when I was working on this head. So I hope you enjoy this, and I hope it gives you a clear understanding of what goes into this. I'm done for the night. I'm probably just gonna go over in the corner and cry or something, you know, after I get done filming this, because it's been that kind of a day. So hopefully tomorrow will be a better day and we'll get this thing buttoned up. But this will give you a good idea. So I hope you enjoy this. So we got the head back from the welder here. The first thing we did was we set it up on the milling machine because it was definitely warped. You can see some of the grinding we had to do in that chamber there. We don't normally set heads up on this machine. It's usually used for blocks. It's a Storm Vulcan 85 Blockmaster, 85B they call it. But because of the strange configuration of this head, the extreme angle of the intake manifold, and you can kind of see that here, the way this thing's bolted to this rollover bar, we had to set this up on the machine. Once we got it milled, then we brought the head over and see, we had to do a lot of shaping and grinding here because there were some big old welds there, so a lot of labor that is not even on camera here. So we stuck a couple of valves in and we started looking at the valve guides. Now this particular head, these cast iron heads, it has what they call an integral or an integrated guide. That means that the guide is actually machined right into the metal of the cylinder head. There's no guide insert or you know, that it can be driven out. So the guides are part of the head. Well, normally we put a dial bore gauge in here, a small bore gauge, and check the guides. However, we didn't have to do this on the 6-cylinder here because the guides were so sloppy, it was obvious that they were bad. So we got the head milled, and now we are in a situation where if you look at the valve movement here, it's like very obvious we got a pretty bad problem. Bad valve guides will cause the engine to burn oil, and it will also cause the valve to rock, and the seat will be upset. It won't seal correctly. And of course, getting these valves to seal correctly is actually one of the main goals of a valve job or a rebuild on a cylinder head. So it was obvious that we were going to have to put guides in it. Well, in order to put guides in a head that has integral valve guides, in other words, the guides are actually part of the head, we literally have to go through, we have to set the head up on a machine, on a cradle, on what we call a seat and guide machine, and we take a core drill and we literally have to bore those guides out. So we're boring them out to a very specific size, and after the guide is bored out of there, we have a much larger hole that we can press a new guide insert into. The hole that we're making here with this core drill is a very specific size because the guide that we put in, we're going to buy a replacement insert guide that actually presses into this hole. So because of that, the size of the hole that we're boring out here
has to be a precision. It has to be a precision hole. So once we actually have two tools that we use. The first step is this core drill where we hog out this big hole, and then we finish that hole with a reamer. So we're going to take our core drill here, and we're going to, and this is the last guide we've actually punched out. You can see the holes there on the left. We've actually punched out the all of the guides here. And if you look at the bottom of this, you can see the core drill is coming through on the bottom of that hole. We're gonna punch through the last hole. The next step after getting all of the guides bored out with the core drill is we actually have another tool. We have a reamer that finishes these bores, these guide bores, to a very specific size. Because the guide bore, the guide hole that we're drilling here, has to be about 3 to 4 thousandths smaller than the guide that actually goes in there, and the guide is pressed in. It's done that way to keep the valve guides that we're pressing in from falling out. Since it is an insert guide in there, if we don't have the right interference fit, we don't have the guide in tight enough, once the head heats up on the car, the guides will start slipping and falling out, and then you're going to have a catastrophic failure. So this is our reamer. We're going to go in and we're just going to finish this hole with the reamer. This is going to cut this hole to a very specific size, giving us the correct interference fit. Once we get all of the holes reamed out, then we have to start looking at our valve guides. We bought valve guide inserts for this head for the customer from SBI, and we have a tool that drives them in. These are the two tools that we just used. This is a core drill and this is a reamer. We probably spent about an hour and a half worth of setup and machine time to bore these guides out and get the machine set up. Now we have our guides. We also have a driver for our guides here. So we're going to take our guide, we have a driver that pilots into the guide, and voila, we put that in the head. So if we look at the cylinder head here, we are going to take, now you want to lubricate these. Because it's such a tight fit, we definitely need to use WD-40 or some type of lube on the guide bore and the guide. It makes it go in much easier. If you don't use lube on it, you're probably going to have a hard time getting that guide in. So once we got it lubed up, make sure you wear eye protection because you're hitting a steel driver here with a steel hammer. We never want to compromise on safety. And just take your driver and we knock it in. Of course, you're going to repeat this all 12 times for all the guides. We're just going to do one for demo purposes here. But again, quite a time-consuming process. Not something you're going to be able to do unless you have the right equipment and the skill to do it. So there's our valve guide. You can see that insert's pressed into that hole. And we're going to repeat that. We have a set of guides. We bought all the guides. Now we did have one oddball guide here, and that is they only had 11 of the guides that were specified for this head. So they gave me another guide, a 12th guide, that was the same exact guide, except it was a ½ inch taller than the rest of them. Well, I'll show you how we address that. Anytime you put guides in, and we got a good fit here, the valves are nice and tight, the clearance is good, everything looks really good, we got rid of all that movement, and we got a really nice set of true, accurate, very well centered guides, and we've actually replaced the integral guides that were in the head. So we get all of our guides in, and then at that point we have to start thinking about what's going on up top, at the top of the guide boss. So the cradle here rolls over, so we loosen up the cradle and we roll the head over it and we look at the top. Now you'll see the one oddball valve guide that I had to use here, and it's not a big deal because we're going to trim them all down anyway. So you can see that up top we have a little bit of a mismatch here, so we want to kind of trim these guides down a little. And then right there we've got that oddball. It's much taller than the rest of them, so we're definitely going to have to cut that one down. We want all these valve guide bosses on top to be exactly the same height, so we don't have any interference or any kind of clearance problems. So we just want to do a real clean trim job up here. But first, of course, we're going to make sure the head is perfectly level. Once we level the head and lock the cradle down, we have a tool called a PC cutter. This is a positive seal cutter. And what this does is it basically just trims all the guides down to a uniform height and makes them all the same. So now that we've got our head perfectly leveled to the machine head, we just put our PC cutter in there and we're going to start trimming these guides. I'm going to run this down and trim that tall guide, that oddball guide first, because that'll be a good example for you guys to see. So I need to cut this guide down until I get it to the exact same height as all the rest of them. And so when you're cutting with this tool, you can feel when the tool bottoms out on the top of the existing valve boss. It cuts a chamfer up there. And it's a real easy way to make sure that all the guides are exactly the same height. You can see all the chips we're cutting off there. So we cut that guide down, and you see it's the diameter of that guide that we just cut is considerably smaller than the other ones. That's because this cutter is designed to set the head up for a special type of valve stem seal that actually clamps onto that guide. So we're sizing that guide boss for that seal. Once you get all the guides cut down, everything is uniform, everything is trimmed. You got a real clean job here. We don't want anything to be sloppy here. We want all the guides exactly the same height. We want them all machined, and that's what we have. So that pretty much concludes the guide installation on this head. We've got the guides in, we've got them sized for the valves, everything looks pretty good. Then we have to start thinking about the valve seats. Now, cylinder heads, and what I do is I measure the size of the seat insert. This is a hardened steel insert that's going to replace the integrated or integral seat. I told you we had integral guides on this head. We also have integrated or integral seats. That means that the seats are machined right out of the metal of the cylinder head, so they're cast iron and they have a tendency to be soft as well. So we want to upgrade this head and make sure it's compatible with unleaded fuel and make sure we have a good base for our valve to seat on. So on the exhaust seats, because they run so hot, it's always a good idea to have hardened seats put in. But before we do that, because they are integral or part of the head, we actually have to go in just like we did with the guide, and we have to cut that seat out. We actually have to eliminate that existing seat with a tool. This is a counter bore cutter here. So we're going to cut a counter bore into this cylinder head. We're going to set our tool though, because it's an interference fit. So this fixture sets the tool up. I measured the valve seat, and now I have to take and set my tool so that it cuts a bore in the head that is smaller than the seat, because the seat is pressed in. It's an interference fit. So once we get that taken care of, then of course we want to re-level our head. So off screen, above screen here, you can't see it right now, but I've got that level in the machining head of this machine, and I'm checking the level on that. I'm going to take the same pilot that I had in the machine head, and I'm going to put it right into the guide. Then I'm going to put the same exact level onto the pilot that's perfectly centered on the guide, and I'm going to make sure that this head is perfectly level to that cutting head. If we don't do that when we put guides and seats in, then if the head's not level, the cradle's not where it's supposed to be, you will actually cut your hole crooked, and then you really got problems. You could potentially ruin the head that way. So we got to be really careful that we get this head nice and level. So once we get it leveled and lock it down into place, then we can begin to cut our counter bores for installing our hardened seats. The seat cutter itself pilots onto the same pilot that we just leveled off of. Now the other thing is, since this machine is a bit like a drill press, I have to also set the depth of my seat. I have to take the thickness of the seat that I'm going to be using. I have to make sure I don't cut this counter bore too deep. And we have a pretty specific procedure for doing that. So we're going to change the driving head and put the correct driving head in here for our seat. We've got our seat driver, our seat cutter rather, and our sleeve set up. The driver just fits up into the machine, and that is going to drive our seat cutter there. So we put the seat cutter, we pilot it down on the pilot, and then we're going to adjust the machine. I'll move the camera here so you can get a real good shot of this. And then of course we're going to, that cutting head is pretty far away from that cutter, so we want to bring that down and get it real close. Makes it more stable when we're cutting. So we're going to bring our whole cutting head down closer, and then we can begin cutting this seat. Now what I'm going to do, there's a couple of, if you look right up, there's a couple of blocks on the head here. I'm going to run this down, and that lock screw on the left, I'm going to run this down till my cutter is sitting right on that seat, and then I'm going to lock that screw on the left side. What that's going to do is that's going to hold my seat cutter down so that it sits right on that seat. So that cutter is sitting on that seat. Then I take my seat that I'm going to use and I put it in between these two black blocks here. But before I do that, I want to take a small cut. I want to actually make sure that I've started cutting, or I'm getting into the seat. So I take a small cut here and I trim just a little bit of material off of the top of that seat area, and that puts me down into the travel of where my seat's going to go, because I want my seat, when I press this seat in, I want it to sit just slightly lower than the surface of the combustion chamber. So I take a little bit of cut, just a little bit of a cut there. Then I put my seat in between these two black blocks and I lock it down. What that does is that sets the depth. So that upper block that I locked up there is only going to let the machine go down until those two blocks come in contact with each other, and then it's going to stop. So then once I've got the depth set, I just proceed to cut the counter bore out. So this, and again, this counter bore is a precision size, because as you're going to see here in a little bit, we're going to have to press this seat in. So once I bottom out on the blocks, now I've got my counter bore cut. I can remove my tool, and you will see that we literally just bored that existing seat right out. We just bored it out of there. It's gone. We're going to have to vacuum all these chips out and make sure this is really clean. The seat is pressed in with a tool. We have it's called a seat driver, go figure. So we're going to vacuum the chips out of there, and then we're going to drive this in with a seat. However, one thing on this head that I discovered was that the counter bore, the bottom of the counter bore, was actually much smaller than the inside diameter of this new seat that I'm putting in. So I stuck it on there, and I noticed that there's a big mismatch here. So because of the mismatch, I want to make sure that I correct that. So I'm going to take this is my seat driver here, and this is the tool that we're going to use to put this in. The seat just sits on there, and the driver it pilots onto the same pilot, and it has a driving head, and we just take a hammer and we're going to knock that seat in. But I don't want to do that just yet. Because I have such a big mismatch, exhaust gases are going to be exiting out past this exhaust seat. And since the exhaust seat is larger, the inside diameter of this seat insert is larger than that counter bore, the bottom of that counter bore, that mismatch is not going to be good. Two things that airflow or exhaust gas for that matter don't like is they don't like abrupt changes in direction or disruption in flow. So leaving this big lip down here and having a mismatch at the bottom of the seat could actually cause a big disruption in the flow and hurt the performance of the head. So I just have an angled cutter, and I'm going to go in here and I'm going to trim this. I want to trim the bottom section of this counter bore to make sure that when the seat is in there, the bottom of the counter bore matches the inside diameter of the seat. We don't have any mismatches here. So if you look close, you can see this. I've actually cut the lower end of this seat. Now I'm going to take just a little more out because I don't feel like I've gone far enough here. So I'm going to cut just a little bit more out of this because I want this to match the seat perfectly. See, it's this kind of stuff right here that the customers don't see. Technically, I could have left this way, but you know, I just wouldn't feel right doing that. So now I've got the bottom of that counter bore cut. And if you, I'll try to zoom in on this so you can get a good look at it. So you can see I trimmed out the bottom of the counter bore to have a perfectly good match with the seat that's going in there. And again, this is the stuff that the customers don't see. Then they question why you're charging so much. They don't see any of this stuff. They don't see all the effort and the work and the skill that goes into this. So once we get that done, then we can drive our seat in. We have a good counter bore, we have the depth right, we have the bottom trimmed out so we don't have any mismatches. We take our driver and we just drive our seat in. And it is a press fit. Once the seat is driven in there, you can see that it's a really good fit. It's sitting just below the surface of the combustion chamber. There's no mismatch on the bottom. Very nicely installed seat. Now the seat itself is a blank. If you look at the seat, there's really no angles on it. It's just a square blank. So the next thing we need to do is we actually need to cut the angles on that seat, or the seating angles. And we use a multiple angle cutter. So the valve itself is cut, the valve face that sits against that seat is cut at 45 degrees. So since we have a multiple angle cutter, we have to know exactly where to set our cutter so that this valve seats in the correct spot. So we have another little fixture here, we put the valve in it, and we have a pointer on the end, and we put the pointer on the face of the valve where we want that 45 degree angle, or we want that seat to be. So we set that up, we make sure that we locate that pointer in the correct spot. Once we get that done, we take the valve out, and this pilot should look familiar. This is the same pilot we've been using all along. We stick the pilot in there, and then we have a cutting tool, or a cutting head. The cutting head pilots onto this pilot just like we're going to do when we cut the seat, and we put our cutter in there. And so since our pointer is set to exactly where we want the valve face to seat, we just line up the 45 degree angle on our cutter with the pointer that we set with our valve. Once we get that done, we lock the cutter in place, and voila, we have a cutter, an adjustable cutter that is set up, and it's gonna cut that seat and put the angles in really close to where they need to be. We may have to fine tune those a little bit with lapping, or maybe touch them with a seat grinding stone, but it's going to get us really close. So we take our pilot, our 3-angle cutter, and it's back over to the machine. So here's our our seat that we just put in. We put our pilot back in the hole. We're going to put a spring here because we really don't want to jam this tool up against the new seat there. Once we get the the cutter set, we get the pilot in, and we line this up to the cutting head of the machine. Then we can take and just go ahead and cut this seat. I will readjust the camera here so that you can see this a little better. But we're going to go ahead and cut the angles on this seat, because right now you just see the edge of that seat's just a square blank. So take a good look. I want you to watch close on the seat. You'll actually see the angles start to appear as this cutter starts to take material. You'll see the angles take shape. When they say, oh yeah, I got a 3-angle valve job, this is kind of what they're talking about, because we're cutting multiple angles that are designed into this cutter. And of course our 45 should be located, since we located off of the valve, it should be located for the valve. Once we get down and we see all those angles appear, then of course we're going to have to clean the chips off of there again, and we can take a good look at our seat. This machine does a real nice job cutting seats, but again, it's time consuming and there's skill involved. So if you take a look at that seat, it's a real nice looking seat. We got our angles there. This is basically what we call a valve job. We're doing a valve job. We're cutting the seats and setting them up for the valves. So we put all the seats in, we cut all the seats. This is our last seat here. We've already cut all 6 of the other exhaust seats, and we're cutting our last seat here. Once we get this cut, we're well on our way to being finished with the machining part of this valve job. However, that doesn't mean that the head's done. We still have more work to do. A cylinder head is very much like a work of art. It takes a lot of finesse and skill and know-how, and also a lot of understanding of how airflow works. But really, we have basically a work of art here. That's probably going to last the customer for a long time. Another thing that I forgot to mention is I had to drill out like 6 broken bolts and put Healy coils in this head. That was about another hour and a half worth of work on this cylinder head, in addition to everything else that we did. So very labor intensive, a lot of labor for a 6-cylinder head, but like I said earlier, we can't find one of these heads anywhere. Nobody's got one. So we're going to remove the head off the machine now, and at this point the head's pretty much done. Other than final washing, we're going to run it through a machine called a jet washer that's going to really do a good job of washing all the chips and everything out of this head. And then we will be ready to assemble the head. So this is the finished product here on the bench, although has not been cleaned yet, has not been final washed. We usually take an air hose and blow it off, get any excess chips out of there. Make sure you wear eye protection when you do this. And then we will final wash the head. Once we get the head final washed and we're satisfied that it's clean, we go over to an assembly area, we set it up on the bench, and we start thinking about assembling this thing. There's a couple of checks you have to do when you start assembling the cylinder head though. We have to, and here we are on the bench, we got our new valve springs. The valve spring height is important. And we've got all of our valves here. We're going to set them up next to the head. We got our keepers, which are wrong. At this point though, when I was filming, I was not aware that they were incorrect. I found that out as I started to put this thing together, or started to check installed height. So installed height is basically once you get your respective valves where they go, the installed spring height, the spring has a specified height that it has to sit at on the head. So when you do things like, get heads welded and replace seats and all that stuff, that can kind of change where the valve sits slightly. So we have to make sure that we measure the spring height on the top of the head. So we have a tool here. This works just like a micrometer. It measures in thousandths of an inch. And this actually just takes the place of the valve spring. So we're going to put our valve in the cylinder head. And once we get and of course when the valve goes in, there's a retainer that sits on top of that spring. And that retainer just goes right up here on the valve. And then of course the keepers go on there. But before we put that on, instead of putting the valve spring on, we're just going to put our tool in place of where the valve spring would be. That way we can measure the height. We can put now of course these are not the right keepers here, so I'm not actually going to be able to do this. I'm just kind of demonstrating it. I didn't know these were the wrong keepers until right now. I just realized that keeper's not right because it's too big. So I'm like, oh boy, what a bummer. So anyway, even though what we do is we put the right keepers in there, and then we run this thing out until it's tight, and then we read it, and it measures the height of where that spring sits, and we just compare that to the spring installed height specs in the book. If we have to, we can put a shim under the spring and kind of adjust this accordingly. But the spring height is very, very important because it assures that the head has the correct opening and closing pressures. It can adversely affect performance if the spring height is wrong.